So, area calculations, sheet 1. Problem 1A. We want to calculate the area between y squared equal to 4a into x plus a and y squared equal to 4b into x minus a. The area enclosed, given that b is greater than a, in fact we want to be able to show that the area between the two curves is 8 root 8 a squared root b by root b minus a is what we want to establish as the area between the two curves, right? The first thing that you want to do is trace the two curves. Let's trace the two curves in the xy plane. What are these? Parabola. Where is the vertex of this parabola? Minus a 0. What about the vertex of this parabola? A 0, right? Isn't it? And assuming a and b are positive, this parabola opens, right? In this case, x has to be greater than minus a in order that y squared is positive, so it will open to the right of minus a, right? Minus a 0 is this point. This parabola has its vertex at a 0, a comma 0. Let me call this P, let me call this Q, A0 is this parabola, right? So this is essentially y squared equal to 4a into x plus a, and this is y squared equal to 4b into x minus a. These are the two parabolas, right? And what I am seeking to find is this area is what I am seeking to find, right? This is the area that I am seeking to find. That means the area above the x-axis would be equal to the area below the x-axis. So if I find the area above the x-axis, I can double it. Right? Now, these are A and B, the points of intersection of the two parabolas. A and B are points of intersection of the two parabolas. Now, if I solve these two equations, I'll get the coordinates of A and B, the intersection between the two parabolas, right? Right. So if I solve for the two, let's say if I solve for x coordinates of A and B, then the x coordinates of A and B will be obtained by equating their y squared. See, from symmetry you can say that y of A will be the same as y of B in magnitude. In fact, y of A otherwise would be minus y of B, and they will have the same x. They'll have the same x. A and B will have the same x coordinate from symmetry considerations, and the corresponding x coordinate is obtained by equating their y squareds, 4b into x minus a, right? So x into a minus b is a into, oh, b is greater than a, right? Okay, in this case they say b greater than a, so let me write it like this: x into b minus a is a into a plus b, right? So the x coordinates of a and b is a into a plus b by b minus a. So once I know the x coordinates of a and b, that is xa, which would be this is the same as xa and is the same as xb, right? I can solve for y of a. How? I can plug the value of x and I can get y. I get two values of y. One would be y of a, the other one would be y of b. So if y of a turns out to be y naught, then y of b will turn out to be minus y naught. Y of b will turn out to be minus y naught. Right? Now, there are two ways I could have approached this problem. So, let's say I know A and B. Can I remove this stuff from here? I know the coordinates of A and B. Now, one of the things that I could have done, the inefficient thing, is the following. First, I'll do the inefficient thing. Let me just look at the upper part of the curve. Let me call this curve 1, let me call this curve y2. So, all the y's here on this curve would be referred to as y1, all the y's here referred to as y2. So, it's essentially this is like y1 squared and this will be like y2 squared for different x's, right. It will be easier to distinguish between the two curves then. Now, just look at the upper part. This is Q, which is A0. This is R. If you project it here, then this point would be R. R would have coordinates XA0. R would have coordinates XA0. Point A. This would be minus A0. This is not the y-axis. This point P would be minus A0, right. This is the curve. What I could do is, I could take strips like this on 1, right. So, all these y's would be referred to as y1s. That means obtained from here. Y1 square would be 4a into x plus a. Y1 squared would be 4a into x plus a. So, then I could have done like a y1 dx, the area of the strip, and I could have floated from minus a to xa, minus a to xa. Hey, but when I do that, do you realize that I end up getting this as an additional area, which was not to be? So, I will have to subtract this area. When I go from minus a to xa, then of all these strips, if I take all these strips, then it will include these strips also. It will include these strips also. Yes or no? Right? Yes or no? These strips would be included. Sorry, these strips. That means it will give me this entire area. It will give me this entire. So, I would have to subtract this then. I will have to subtract these strips. And the y's here are given by y2's. What are y2's? The y2 squared would be 4b into x minus a. So, I will have to subtract y2 dx. X runs from a to xa. X runs from a to xa. That will be the area of this region. That will be the area of these crossed lines, isn't it? Isn't it? And then once I evaluate this, then I double it. That will give me the area below as well, right. Instead of doing this, a better way to handle this would have been as follows. Can I wipe this off? You can. I hope all of you realize what we did here and you're comfortable with it, right. But this is not what you should have done. Okay, what you should have done is, so the choice of vertical strips I claim is inefficient in this case. It will work all right, but it's not good. What I do is I take these horizontal strips. Now, in this case, if I solve for x in terms of y, that will be x1. In this case, if I solve for x in terms of y, that will be x2. So, then this point would be x equal to x2 for a given y, and this point would be x equal to x1 for a given y. For a given y, x1 would be y squared by 4a minus a, x2 would be y squared by 4b plus a. So, what would this length be? x2 minus x1. What would this thickness be? Small change in y, that means dy. Therefore, the area of this strip is going to be what? x2 minus x1 dy. Right? Now, I take these strips starting from this point where y is 0 and go all the way to this point where y is y0. y is 0 to y equal to y naught. And y naught we have obtained by solving for the two equations, right? And then I double it, because the area below. Realize that I have got the area in one shot without involving two integrals. And what is x2? x2 is y squared by 4b plus a, which is the x of, this is curve 2, right? And what is x1? x1 is y squared by 4a minus a. So just do a x2 minus x1 from here. Just do a x2 minus x1 from here, plug into this, integrate with respect to y, very simply, and you will have the total area that you were seeking. Do you all understand this? No discomfort? Let me illustrate a little more. You make sure that you get the answer. Don't leave it at this point. I have told you in the past, and it's become cliched now, that I don't have to appear for exams, so I have the luxury of doing this. You don't. You have to get to the point of coming to the final fair answer. Okay? Don't do what I do. Just don't do what I do. Right? Find the area bounded by y equal to box, greatest integer function, e power x minus e power mod x divided by e power x plus e power mod x and y plus x squared equal to 0 and x equal to 0. X equal to 0 is the y-axis, x equal to 0 is the y-axis. Area bounded by these three curves, given that x is only less than or equal to 0. For the region x less than or equal to 0, find the area bounded by this curve, which is y equal to box of e power x minus e power mod x divided by e power x plus e power mod x, the parabola y equal to minus x squared, and the y-axis, which is x equal to 0, only for x less than or equal to 0. Clear? Now, let's start tracing things here. So, for x less than or equal to 0, what would mod x be? Minus x. Right? Let's simplify this. This is the only thing which looks a little awful. So this is like e power x minus e power minus x, because mod x will be minus x, divided by e power x plus e power minus x. Yes or no? This is like box of 1 minus e power minus 2x divided by 1 plus e power minus 2x. Yes or no? 1 plus e power minus 2x. Now, one thing, the denominator is bigger than the numerator. So this is less than 1 for sure, numerically less than 1. The magnitude of the numerator is more than the magnitude of the denominator is more than the magnitude of the numerator. So for this expression, 1 minus e power minus 2x divided by 1 plus e power minus 2x for sure will always be less than 1. Numerically, mod of this will be less than 1. The numerical value of this would be less than 1. However, see, x less than 0 means e minus 2x will be positive. So this will be greater than 1 for x less than 0. Yes or no? So 1 minus this would be negative, right? So the numerator is negative, which means the denominator is positive. The denominator is positive, and therefore this expression is negative. The denominator is positive, numerator is negative for x less than or equal to 0. That means 1 minus e power minus 2x by 1 plus e power minus 2x would be less than 0, because the numerator is negative, denominator is positive for x less than 0, right? Which means what? This expression is numerically less than 1 and negative. If an expression is numerically less than 1, that means it has to be to the right of 1, right of minus 1, and negative means it has to be to the left of 0. That means this expression 1 minus e power minus 2x by 1 plus e power minus 2x must lie between minus 1 and 0. That means box of this will be minus 1. Box of this will always be minus 1. So this y is simply minus 1, not really as clumsy as it appeared when we started, right? Y therefore is minus 1 for x less than or equal to 0. Clear? Now, once we obtain this, let's start tracing the other entities that belong to this. Y equal to minus x squared is a downward opening parabola. Y equal to minus x squared is a downward opening parabola and will be looked upon like this. This is y equal to minus x squared. Right? And this is x equal to 0. This is x equal to 0. Right? And this curve is y equal to minus 1. Y equal to minus 1 is this. Right? And therefore the area that we are seeking is this area. This is the area that we are seeking. Area between y equal to minus 1, this curve, and x equal to 0. This is the area that we are seeking. What we could have done is, we could have selected strips of this kind. Yes or no? Where realize that this minus this would be a negative number, isn't it? Because, isn't it? Y of this minus y of this will be a negative number. Because if you're going down further, the y's are decreasing, right? Therefore, y of this point minus y of this point will be a positive number. But y of this point is what? Minus x squared. Minus x squared minus y of this point. Y of this point is minus 1. So minus minus 1 into the thickness of the strip, which is dx. That's the area of the shaded strip. Right? That's the area of the shaded strip. And what would this point be? When y is minus 1, when you plug in y equal to minus 1, x will be minus 1. So this point is x equal to minus 1. Right? So this strip would be y of this point, which is minus x squared, minus y of this point, which is minus 1, right, into dx. And we want to sum it up starting from x equal to minus 1 to 0. X equal to minus 1 to 0. dx's are selected in the direction of increasing. We'll prefer to choose dx's in the direction of increasing x's. So x is increasing in this direction. So we get x runs from minus 1 to 0. That will be the area of this dotted region. Clear? Bolo, confusion? You could have also selected horizontal strips. So let me also tell you how you could have dealt with this situation by selecting horizontal strips. This is y equal to minus 1. Select a strip of this kind. Select a strip of this kind. For a given x, this y would be minus x squared. For a given x, this y would be minus x squared, yes or no? Right? This is a small change in y, dy. What would be the x then? X would be minus of root minus y. X would be minus of root minus y, isn't it? When I solve for x from here, x would be minus of root minus y. And see, y's are negative, so minus y will be positive. And then since x's are negative, I plug in a minus sign, right? That will be my x. So this length would be simply mod x. I'm right, to calculate the area I need this length. This length would be mod x. And mod x would be root minus y. Mod x would be root minus y. That will be mod x. This length would be mod x. It's not x because x is negative. So into this thickness dy is the area of this horizontal strip. Clear? And I want to sum it up. I want to sum it up starting from y equal to 0 to y equal to minus 1. Yes or no? Y equal to 0 to y equal to minus 1 and take the modulus. Right? That will be the area if you chose horizontal strips. You will get the same answer. Which case? No, in this case it's not required. It's anyways coming out to be a positive number. See, where is the negative number? I've taken y of this, which is more than the y of this. Y of this is minus x squared, which is more than minus 1. So this anyways is positive and dx's are positive. So this number is anyways positive. Where x runs from minus 1 to 0, you're not going to get a negative number out of this. Still, if you choose a modulus, you can be safe about it, not a problem. Clear? It's not required in this case. We want to find the area enclosed by y equal to x ln x and y equal to 2x minus 2x squared. Y equal to 2x minus 2x squared is a downward opening parabola with roots 0 and 1. Right? Let me draw the graph of x ln x. Right. Now, as x tends to 0, it tends to 0. Right? X ln x tends to 0 as x tends to 0 from the greater than 0 side. Right? For x greater than 0 less than 1, ln x would be negative. So x ln x is negative. Right? That means to the left of 1 and to the right of 0, the graph of x ln x will be below the x axis. And for x greater than 1, x ln x will be positive. Right? That means to the right of 1, it will be positive. And as x tends to infinity, x ln x will tend to infinity. Right? Okay. Which means as x tends to 0, it tends to 0. At x equal to 1, it's 0. and between 0 and 1 the graph is below the x-axis. So you would expect, even without doing too much hanky-panky, you would expect the graph to be something like this, yes or no? Which means between 0 and 1 you might expect a local minimum. Let's check that out. Let's check that out, right? Y equal to x ln x. That means a turning point between 0 and 1 where y is x ln x. dy dx is ln x plus 1, and it will become 0 at x equal to 1 by e, right, which is between 0 and 1. At x equal to 1 by e, it does become 0, and d2y dx2 at x equal to e is 1 by x, which is positive for all x greater than 0. That means d2y dx2 positive and dy dx 0, so it must be a local minimum, right? So at x equal to e, a local minimum, and the graph goes like this. This is the graph of y equal to x ln x. What do you say? Right? Now, the parabola y equal to 2x into 1 minus x has roots 0 and 1 and is downward opening, so it will have a loop between 0 and 1 like this. Right? And I want to be able to find the area between the two. So what we are trying to do is find this area. Now this 1 by e will not even matter. This is the area that we are seeking, right? We select strips of this kind. The height of this strip is y of the parabola minus y of the graph x ln x, right? This length would be 2x into 1 minus x minus x ln x, right? That will be the length, right? And of course, each of these strips, as is customary, is selected of length dx. So 2x into 1 minus x is the y of the parabola minus y of this, which is x ln x, will give me this length. The whole into dx, where x runs from 0 to 1, will be the required area, This is easy to integrate. So is x ln x if you integrate x ln x. By parts, ln x into x square by 2, x runs from 0 to 1 minus x square by 2, so x by 2 dx, x runs from 0 to 1 is what you get, right? I hope you realize what I have done here. And this will be 0. Why? Because at x equal to 1, ln x is 0. As x tends to 0, x ln x will tend to 0. So x square ln x will also tend to 0. You know what I'm saying? So this will be 0, and this will be x square by 4, which will be minus 1 by 4, which will be minus 1 by 4. So you can just plug into this, evaluate this integral, and get the required area. Is that all right? Find all possible values of b greater than 0, so that the area of the region enclosed between the parabolas x minus bx square and y equal to x square by b is maximum. Y equal to x minus bx squared and y equal to x square by b, the enclosed area, we want this to be a maximum. For that purpose, we want to be able to model b. Evaluate b, for which this is. So let me first draw the two parabolas, right? The first one is a downward opening parabola with roots 0 and 1 by b, and 1 by b. is this parabola with one root being 0, the other root being 1 by b. That's this parabola. This is a typical upward opening parabola, y equal to x square by b. X square by b. This is y equal to x minus bx square. Right? This would be the x of the intersection of the two parabolas, right? At this x, the y's become the same for the two parabolas. So, to solve for this x of intersection, equate their y's. X square by b is x minus bx square, or x is 0 is one of the points of intersection, which is anyway is trivial. The other point of intersection then would be 1 divided by b plus 1 by b, say x naught, right? Now we want to find b such that this area is a maximum it could be. We want to maximize this area. Find b such that this area is the maximum it could be. So how would you do it? You would select vertical strips of this kind. The length of the strip would be y of the upper parabola minus y of the lower parabola into dx. Y of the upper parabola is x minus bx squared minus y of the lower parabola would be x square by b into the thickness dx of the strip. Sum up all the areas starting from x equal to 0 to x equal to x naught. That will be the required area. Right? Now let's simplify matters here. But so far so good, right? Where x naught we have figured out is b plus 1 by b. Alright. Let's simplify things here. This would be x dx, which would give me x naught squared by 2, right? Minus b plus 1 by b x square, which would be x cube by 3. Yes or no? Right? So which would be x naught cube by 3. Oh, x naught was 1 by b plus 1 by, yeah, sorry, x naught was this, right? So this then is x naught squared, which is half of 1 by b plus 1 by b whole square minus 1/3. This would be 1 by b plus 1 by b whole square. Which would be 1/6 1 by b plus 1 by b whole square. That would be the required area. Clear? Now A will be A max when b plus 1 by b is minimum. And what's the minimum value of b plus 1 by b? 2. And that happens at b equal to 1, isn't it? So, right, arithmetic mean greater than or equal to geometric mean will give me this greater than or equal to 2, isn't it? B plus 1 by b by 2 arithmetic mean greater than or equal to geometric mean, which is 1 for b greater than 0, right? So, this area, which is maximum when b plus 1 by b is minimum, that means when b plus 1 by b is 2, and that happens at b equal to 1, a minimum occurs, a maximum occurs, maximum A occurs, and the minimum of b plus 1 by b occurs at b equal to 1. Clear, no? In what ratio does the x-axis divide the area of the region bounded by the parabola y equal to 4x minus x square? This parabola has roots 0 and 4. This parabola has roots, this quadratic has roots 0 and 4. Right? Isn't it? So it will loop between 0 and 4, a downward opening parabola looping between 0 and 4. Whereas this parabola, which is y equal to x squared minus x, which is an upward opening parabola, and it will loop between 0 and 1. It will loop between 0 and 1. Upward opening, but will loop. So then, let me call this curve 1, let me call this curve 2. The downward opening parabola like this, looping between 0 and 4. This is, all the y's are referred to as y1s here, right? This is an upward opening parabola looping between 0 and 1. And all the y's on this parabola referred to as y2. Right? We want to find the ratio of this area and this area. Right? So, the first thing that I could do here is, let me find this area. Let me find this area. How do I find this area? Horizontal strips is not a good idea, because see, if you write x as a function of y, you have to solve for x, which is a quadratic, which will be cumbersome, isn't it? So to take horizontal strips looks good, but it has algebraic deficiencies in using that, right? Huh? So vertical strips is what I'll do, but yes. Say their points of intersection, their point of intersection is x naught, which is this x naught. So I take these strips from 0 to x naught. From 0 to x naught, I take these strips. I get this, and then this would be the additional area that I get. This would be an additional area which I will have to subtract to get this area above, the area above. The area above is A1, the area below is A2. So to get this A1, I will have to calculate this area under this curve is y1. So to get these, I take y1 dx to get area all the way up to x naught, y1 into dx, right? Where x runs from 0 to x naught I'll obtain, when I solve these two, I'll obtain x naught. X runs from 0 to x naught, right? But in the process of doing these vertical strips, right, y1 dx, y1 dx, y1 dx, I get this as an additional area, right? The additional area, from 1 to x naught, and it lies under the curve y2. The additional area lies under the curve y2, yes or no? This is y2, right? So then I'll have to take these strips, y2 dx. I'll have to subtract the strips y2 dx, where x runs from 1 to x naught, yes or no? So minus integral y2 dx, where x runs from 1 to x naught. This was the additional area that I was talking of. See, these strips are all y2 dx's, y2 dx's, y2 dx, y2 dx, x runs from 1 to x naught. That will be the required area A1, where what is y1? y1 is 4x minus x square. What is y2? x square minus x. I can readily evaluate this, and you can solve for the point of intersection. Have you done that already? How much? X naught is 5 by 2. Okay, as some of you have already obtained, x naught is 5 by 2, which you can plug in to numerically obtain A1. Now what about A2? 0 to 1. I'll take strips of this kind on the curve 2. So these lengths would be y2, thickness dx. So y2 dx, where x runs from 0 to 1. This will give me a negative area because all the y2s are negative. So I'll take the modulus of this to get the required area A2. See, these y2s are negative, so y2 into dx will be negative. So these areas would, this area would be negative. I take the modulus to make it positive. And then A1 by A2 to get the required area, ratio, to get the required ratio. Find the area enclosed by y minus sine inverse x whole squared equal to x minus x squared. So essentially, you know, it's two curves, because this is like y minus sine inverse x is plus minus root x into 1 minus x. We are talking of a curve which is y equal to sine inverse x plus root x into 1 minus x, and another curve y equal to sine inverse x minus root x into 1 minus x. These are the two curves that we are talking of, isn't it? We want to find the area between the two curves, therefore. We are therefore trying to find the area between the two curves, right? Now, they intersect at 0 and 1, isn't it? You can see that these curves intersect at 0 and 1, at x equal to 0 and at x equal to 1, they intersect. And this curve is above this curve, right? Therefore, this curve, let me call it curve 1, let me call this curve 2. Curve 1 is something like this, and curve 2 is something like this, between 0 and 1. Right? We look at strips of this kind, which is y1 minus y2 into dx. So y of curve 1 minus y of curve 2 into dx, where x runs from 0 to 1. That will be the required area of this dotted region. Y1 minus y2, which is twice root x into 1 minus x dx, x runs from 0 to 1. How do you integrate this? Yeah, or in this case I would rather just take x equal to sine square theta and proceed. Theta runs from 0 to pi by 2. I'll do this for this case. This is what I'll do for this case. Put x equal to sine square theta and proceed. That will be a effective option. See, I didn't draw the exact graph. All that I'm saying is, in the interval 0 to 1, this is above this. And they intersect at 0 and 1, at x equal to 0 and at x equal to 1. How else could it be? If they intersected at 0 and 1, and one graph is strictly above the other graph. That's all. No. The point is, in the interval 0 to 1, this is bigger than this. So, even the smaller one is positive. Isn't it? Even the smaller one is positive. So the difference is positive anyways. Right? You'll be able to integrate this with x equal to sine square theta. Find the area bounded by y equal to cos x from x equal to 0 to 2 pi. we want to find this area. This is y equal to cos x from minus pi by 2 to 2 pi. Right? This is the graph of y equal to cos x. All that you need to do is you find just this area and 1, 2, 3, 4, 5 times this area, isn't it? So the required area is going to be 0 to pi by 2, 5 times cos x dx will be the required area, right? We want to find the area bounded by y equal to x squared. This is y equal to x squared between y equal to 1 to y equal to 4. Between y equal to 1 to y equal to 4, that means this is the area that we are seeking. What would you do now? Take horizontal strips this time. So take a strip of this kind. This length is x, this is dy. So the area of the shaded portion would be x into dy, where y runs from 1 to 4. Y runs from 1 to 4, that will be the required area. And now x you can put as root y. Y runs from 1 to 4. That will be the required area. We want to find the area enclosed between sine inverse x, cos inverse x and the x-axis. See the graph of y equal to cos inverse x. At x equal to 0, cos inverse x is 0. At x equal to pi by x equal to 0, it's 1. At x equal to pi by 2, it will be 0. This is the graph of cos inverse x. This is y is cos inverse x. The graph of y is sine inverse x. At x equal to 0, it's 0. At x equal to pi by 2, it will be 1. This is the graph of y equal to sine inverse x. And they intersect at x equal to pi by 4. At x equal to pi by 4, both are equal to 1 by root 2. Right? And what we are seeking is this area. This is the area. From 0 to pi by 4, cos inverse is higher than sine inverse. And from pi by 4 to pi by 2, sine inverse is higher than cos inverse. So from 0 to pi by 4, I'll take these strips. These strips are cos inverse minus sine inverse. And then from pi by 4 to pi by 2, these strips are sine inverse minus, this is sine inverse, this is cos inverse. So dx. This is what you need to do. Clear? We want to find the area of the region enclosed by x minus 1 whole squared by 4 plus y minus 1 whole squared is 1 and y minus 1 whole squared is 3 by 4 x minus 1. Instead of making things complicated, what we can do is this x minus 1 I can select as capital X, and that y minus 1 I can select as capital Y. So then in the capital XY frame, the area will not change if you, right, the area will not change if you did this. So this will be like x square by 4 plus y squared by 1 equal to 1, which is an ellipse, and this will be like y squared equal to 3/4 x, which is going to be a parabola, right? This ellipse is center capital X equal to 0, capital Y equal to 0 is this ellipse, right? This is the major axis of the ellipse. This would be capital X equal to 2, 0, minus 2, 0, right? And the parabola, again, the vertex of this parabola is capital X equal to 0 and capital Y equal to 0, same as the center of this ellipse. This would be the parabola y squared equal to 3 by 4x. And can you not find the x, capital X naught of intersection of the two? Right? When you solve this, put y squared equal to 3 by 4x. You will be able to find x naught, the point of intersection, right? Now, you will then look at this area, for which you will consider these strips, and then you look at these strips, which will give you this area. Yes or no? Two different sets of strips. Capital X runs from 0 to x naught and then x naught to 2, right? These strips are like y of the parabola into dx. Y of the parabola is what? Root 3 by 2. Root x, that's the y of the parabola, into dx. That's the area of this chosen strip. Sum of all of this, where capital X runs from 0 to x naught, plus integral the area under the ellipse, which means y of the ellipse. Y of the ellipse is going to be root 1 minus x squared by 4 into dx, are these strips where x runs from x naught to 2, right? And then you double it, because there is the same area below also. Suppose this is A, then the required area will be 2A. The same area below. Right?